Hey there, I want to talk to you about how to do some linear regression modeling in RStudio. So what I've got here is some data, and what I've collected is some data on the women's mile, the world record as it has changed over time from 1921. I've got it up here to 1996. So, like 1921, the world record was just over 6 minutes for the women's mile, and then 1996, just over 4 minutes. And I want to take a look at this data, and to do that, I'm going to make a plot here. And the plot, my independent variable, the x, I'm going to make that the year. And for the y, the dependent variable, I'm just going to set that as the world record. And I'm taking a look at this thing. And it doesn't look like it's a perfect linear relationship, but it certainly looks like over time this thing is going down in a fairly linear fashion. So I'm looking at that saying, okay, what can I do to find the model that fits that data? Before we do the linear model, we usually calculate correlation, and to do that the command is COR, and when you calculate correlation you just want to use the same x and y variables that you did for your plot. So the women's mile, the year for the women's mile, and then the record was the dependent variable. So it looks like my correlation here is negative 0.9685978. Now that correlation can only get to -1, so that's a pretty strong correlation there, strong and negative. So I'm definitely thinking there's a linear relationship here. That's what that correlation's telling me. So how do I figure out what that relationship, or how to model that relationship? Well, we do that with a linear model, and in R, the code for that is going to be summary and LM for linear model. And inside the parentheses here, it's a little confusing. Instead of going independent, comma, dependent, we actually do the dependent variable, so we switch it. We're going to do the women's mile record, and then it's a little tilde, which is the button right above the tab button. Women's mile, and then it's the independent variable, so year. And when I run this code, I've got all this interesting output here, a lot of different things. Well, essentially the things I'm actually interested in are right here, the intercept, this is the slope, and I've got the r squared. So I kind of want to just pull those three things, and because I'm not really interested in all this other stuff right now. Maybe at some point I would be, but if I just want to simplify my life and I just want to see the actual model, I'm going to create an object here. I'm going to call it model, and inside I'm just going to put the same exact line of code. I'm going to turn that whole thing into model, and you can see that model appears here right underneath my data. It says a list of 11. It's going to store some stuff for me, and I just want to pull out the pieces of that. So I'm going to get rid of all this mess. I'm going to clear that out, and now I just want to know model I want the slope, and the slope of that model is the very first coefficient. Or sorry, that's the y-intercept is the very first coefficient. The slope is the second coefficient in that list of 11 things there. So if I pull out this second coefficient, I've got the slope. So let's talk about what each of these numbers mean here. If hypothetically the year was 0, which is preposterous, I know, but if it was hypothetically, the y-intercept of this linear model would be 52 minutes. So we would predict that based on this model, in the year 0, the women's mile record is about 52 minutes, and And it's one of the dangers of extrapolation. We'll see another danger of that in a moment here. Just be careful with your model. You don't want to make predictions outside of the actual data you have. We have data beginning in 1921, so we probably don't want to be making predictions about the year 0, which is why this number doesn't make a lot of sense in context. But this number is interesting because this is the slope. The second coefficient in there is the slope. And what that is, if I actually take it, this is in terms of minutes, so if I multiply it by 60 to get it in seconds, what that's telling me is that based on our model, the world record for the women's mile is dropping by almost 1.5 seconds every year, according to the model. Now, that's interesting information. So we've got the y-intercept here. So that's the y-intercept. We've got the slope of the linear regression model. The last thing I need, or I guess the last thing I'm interested in, is the r squared. And the r squared tells me lots of interesting things. First off, it's really, really high. Remember, r squared only goes between 0 and 1. This one's 0.938, which means this is a really good model. I could tell that from the scatter plot. This looks basically like a linear model, and the r squared's confirming that. It's the proportion of variance explained, the proportion of variance in the world record time explained by the year. We're able to explain like 94% of the variance. That's really high. And because it's really high, I think that this model that I've gotten, and the model is y equals 0.024 12018 times x plus 52.12724. We think that that model is pretty representative of the data that we have here because that r squared is so high. So how do I see it like on my scatter plot? I want to actually see that line go through there. Well, the way you're going to do that is with the command AB line. And inside this command is going to be the exact same linear model that we ran with the summary command. Right there. And now I can see that that line is going right through the data. Now, some of those points look like they fall on the line, but not all of them do. In fact, most of them don't look like they're on the line at all. The distance between the actual observation and the linear regression equation line, in this case, that would be called a residual. And the residual is calculated as the actual data point minus the predicted data point. So let's say I wanted to make a prediction. Let's say I wanted to make a prediction for the year 2019. Well, I could take my model and I could plug in for that x. The independent variable would be times 2019. When I calculate that, I'm getting kind of a strange value here. Oh, I'm sorry, that's supposed to be a negative, isn't it? Whoops. Try that again. That's a strange value too. 100 was strange. This one's strange. This predicts that in the year 2019 that the women's world record would be under 3.5 minutes. Well, let me tell you that in 2019 it's about a second faster. It's about the current world record is 4.2 minutes essentially. So it's fast, but it's not this fast. So that's a danger of extrapolation. Trying to make predictions outside of your data set. Our data only goes up to 1996, so we really shouldn't be making predictions about 2019. So the residual for that then is the actual value, which is like 4.2 minutes because it's basically the same as 1996. It's just like a second faster. Let's say it's 4.2. It's that actual minus the predicted, and so that would mean a residual of 0.78. And so that's all the interesting stuff that we can do to do linear regression here. Now, you can do some things to pretty up your scatter plot a little bit. Like if you want to do an X label down here, you could set it to be so it says year, and you could set the Y label, and we could make the Y the record time, and that just kind of makes my scatter plot look a little bit more official there. But by and large, this is the process. So we made a scatter plot, we looked at it, we made the model using the LM command, which is linear model, and then when we decided that the model was good, we used the command AB line with the linear model in there to go ahead and graph it. So thanks for watching. If you have any questions, just type them up in the comment section and I'll get back to you. Thanks.